Kia ora koutou, my name is Jessica Cathro and I am the Managing Director for the North Island at Ministry of Inspiration. Welcome to our talk today. The focus of this session is to show you how to use electronics to teach local curriculum. So the idea of using electronics is to depict a story, event or sculpture. I recommend that you pre-teach the electronics and then combine it with the local curriculum. I would not recommend teaching both at the same time, as the troubleshooting for starting electronics can be very time consuming and distracting. In this session we're going to look at the basics of electronics, create a basic circuit, a basic plus circuit, move into an intermediate circuit, and then look at a coded circuit. The idea is that you will then have the basic electronics knowledge to then incorporate and make beautiful sculptures. So, start off with the basics of electronics and what a circuit is. A circuit is a flow of electricity. It comes from the positive side of the battery and it flows through each of your cables, through the LED or the motor, and then round until it gets back to the negative. Once you know what the circuit is, it makes troubleshooting a lot easier, as you are looking to follow the flow of electricity from the positive side through to the negative side, checking that each item is connected and that the electricity isn't skipping any items due to misconnections, incorrect connections, or what we'll talk about a little bit later. So the next thing to explore is what is conductive and insulating. So conductive means that the electricity flows through it, like us, we are conductive, and Play-Doh is conductive. Insulating stops the flow of electricity, things like electrical tape, plastic, or clay. If the flow of electricity goes into the Play-Doh and there is other Play-Doh touching it, it will go through the Play-Doh because there is less resistance. Resistance is something that slows the flow of the current of electricity. An LED is more resistant than Play-Doh because the Play-Doh has more water in it, and water is very, very conductive. Another way of introducing resistance into the circuit is to have a lot more Play-Doh. So if you take a roll of Play-Doh and you roll it up, then the electricity has got to go further to get to the other side, so there is more resistance there. Electricity likes to take the path of least resistance. So if our Play-Doh is touching here like this, then the electricity would rather move between these two pieces than to move through the LED where there is more resistance. So that's why we always need to make sure that there is some clay in between that Play-Doh and between each layer of Play-Doh, otherwise your LEDs or other items will not move or turn on. So let's build our first circuit. You can follow along with these activities on your own. The items that we're using are freely accessible. If you just pause the video, go grab your things, I'll wait for you. So for this circuit we need a power supply. I'm using a 9-volt battery and a battery holder. I'm using an LED and some Play-Doh and clay. My Play-Doh and clay just came from the $2 shop and from Kmart. There is nothing special about it. The battery holder has had the end stripped so that the metal under the plastic is showing, because as we said earlier, plastic is an insulator. You can use a pair of scissors or a wire stripper to do that. In the following slides, we will also use a breadboard, some jumper leads, and an Arduino. Alright, so let's do it. So what we have is our LED. That long line there, that is our positive side. We're just going to bend it a little bit so that we know that that one is our positive side. We've got our 2 balls of Play-Doh. They don't have to be very big. And we've got our layer of clay. It just needs to be big enough to stop the 2 from touching. We've got our positive side, and that's going to pop into one, and our negative side, which pops into the other. Remember that bent line, that's our positive side. That's going to go into the same side as our red, our positive side. And it's going to put our negative into the other side, and now our little light will turn on. So remember, our power is going from our positive side into the Play-Doh, into our LED, through the LED, up the other side. back into the Play-Doh, and back around through our power cable into our battery. So that's our nice, easy, basic circuit. What we're going to do next is connect our basic circuit onto a breadboard, because that will allow us then to add other LEDs feeding into our breadboard as well. So for this one, you need everything we already had, plus 2 jumper cables. Does not matter which color they are. I've used red and black to make it easy to see which ones are working for positive and negative, but any color is fine, and a breadboard. So what we're going to do is take that breadboard and our 2 jumper cables, and we're going to take our positive power and put it into the positive power line on our breadboard. If it's not marked with a plus, it might be marked with an X. And then we're putting our negative cable into our negative side, and that might be marked with a Y. Then we're going to take our black cable, and we're going to take it from our negative side and put it into our negative side in our circuit, just like we had before. So we've got our negative one in there, and we're going from the negative to where our negative used to be. Now we're going to repeat the same thing with our positive, going from our positive line, through into our positive side where we were. You can put this plug anywhere along here, and the same our negative one anywhere along here. So if you wanted to have the stars for Matariki, you could have another positive one, and another positive one, and another positive one, etc., etc., and have this set up 7 times. All fine. So that's how we use a breadboard to hold and connect to our circuit. For our next step, we're going to take this and connect it up to an Arduino. Arduinos are just little computers that allow us to program what our circuits can do. So we can turn our lights on for a certain amount of time and turn them off, so they're little twinkles. We can also program motors to run forwards, backwards. We've got all kinds of things. So to start with, we're just going to swap it onto a Arduino. So for this, you'll need your Arduino, you'll need the plug that comes with it, and a computer. So we're going to take our power away, because our power is going to come out of here. If this cable is connected to our computer, then we have power. So to start with, we've got that power cable running down our power line, just like we had last time. Now here on your Arduino, there's a little one. It says 5V, stands for 5 volts. This is like the power cable that came from our battery. So we're going to go from 5 volts into that power line again, our positive side, just like we did with our just converting to a normal breadboard. Then what we've got is here, there's one that says GND. There is more than one GND. You can use either one, it's fine. We're going to take our GND cable and we're going to put that into our negative line, just like we did with our power cable before. So it's our GND coming into that negative line. Then we can take our negative one, just like we had before, and plug that straight into our minus one. And as you can see, our light is on again. If we disconnect this cable from our computer, we will lose power and it will not work. You can also plug a battery pack into here to give it power so it will work without a computer. No worries. So let's have a look at how we can use our computer to make things twinkle. So now that we are connected in here, we're just going to take that one out. We're not going to just give it power anymore. We want it to do something. So that power cable now has to come into one of these. And I've put it into pin 9 because pin 9 is already pre-programmed to twinkle. So it's that simple. You don't need to change anything else here. All you're taking is from this. We're taking the power and we're putting it into a pin. Now, once you are on a pin, we can take our code and we can make it do things. So we've got two options. You can use Arduino, which is a text-based code, or you can use a block-based code using MBlock. My computer has issues with using MBlock. It does not like to connect to Arduinos using that. So I use the text-based, but my computer is just funny. So if we have a look here, what we've got is set our digital pin, and this is where you plugged it into. So if you plugged it into 9, you'd put the number 9 in here. But if you plugged it into 8 or 7 or 12, like, there is no limit. You can plug it into whichever one you like. Then we're going to set it as high. High means on. Then we're going to wait 1 second, or however long you want. And then we're going to set that same pin, that same number, to low, and low means off. Then wait however long you want to wait. So we can change these numbers to make it turn on quicker or slower. But remember this, our digital pin, that's the pin, that slot that you plugged it into on the Arduino. The same thing is happening over here. Most of this is pre-populated, like this bit here and this bit here, so don't stress about those. This bit here is just saying which pin you are using and that it's going to be an output. We're not taking information off of it. So this one here, LED underscore built in, that's our pin 9. If you just take that whole section and you write 12, done. Then here, digital write is the same as set, that output. So again, I just switch this to wherever you plugged it in. And high, just like over here, means on. Delay is the same as wait. And this number, Arduino works in milliseconds, so 1000 is 1 second. So again, you can play with this number, make it really big, make it really small. Digital write, put the pin number in there, and then low is off, and we've got our delay again. So if you have multiple LEDs, you just copy that whole code, plonk it in again, and put the different pin number that's in there. So if you've got 7 for Matariki, or 9, depending on which constellation you're running off of, you could have that whole thing there 9 times, that thing there 9 times, each with the different numbers, and that would all work. Then you go through and upload it, which we're not going to look at here because depending on your computer, a whole bunch of different ways. So just upload your code and off it will go. So once you've got those basics of electronics, then you can start going into using motors. You can use copper tape instead of a Play-Doh. You can solder your connections. You've got lots of options. So this one here is what a young person created. They've got their plane, it's got lights, the propellers are running. All of that is just run off of their battery pack. Same thing, you can see the positive and negative wires coming in and out. And that's just something that you can look at. This is my less than exciting whirlpool. So again, plugging in through my breadboard into my Arduino. If you'd like more information or you want to share some of your cool ideas, we've got our website here, Ministry of Inspiration, where you can email me, jessica@ministryofinspiration.org. I hope that's given you some ideas on how you can use electronics a little bit differently to set up and build and create. Thank you.